Light is everywhere. It allows us to see the world, powers plants, carries information across enormous distances, and makes many modern technologies possible. But what exactly is light? At first, light seems simple. We turn on a lamp, the room becomes bright, and we can see the objects around us. But when scientists began studying light, they discovered something much more fascinating. Light is a form of electromagnetic radiation. It carries energy through space and can travel even where there is no air or other material. In fact, sunlight travels through the vacuum of space for about 150 million kilometers before reaching Earth. One of the most amazing properties of light is its speed. In a vacuum, light travels at approximately 299,792 kilometers per second. That's so fast that light could travel around Earth more than 7 times in just 1 second. But what exactly is moving? Light can be described using both waves and particles. This is known as wave-particle duality. As a wave, light has a wavelength and a frequency. Different wavelengths correspond to different types of electromagnetic radiation. The small portion that human eyes can detect is called visible light. It includes the colors of the rainbow, from red and orange to yellow, green, blue, and violet. But visible light is only a tiny part of the electromagnetic spectrum. Beyond visible light are radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. They are all forms of electromagnetic radiation, but they have different wavelengths and frequencies. So, why do we see different colors? It depends on how objects interact with light. When white light reaches an object, some wavelengths may be absorbed while others are reflected. The wavelengths that enter our eyes determine the color we perceive. For example, a red object reflects more red light toward our eyes while absorbing much of the other visible wavelengths. Light can also behave in some surprising ways. When it passes from one material into another, such as from air into water or glass, its direction can change. This phenomenon is called refraction. Refraction is responsible for many familiar effects, including the apparent bending of objects underwater and the way lenses focus light. Light can also be reflected. When light hits a smooth surface, such as a mirror, it can bounce back in a predictable direction. This allows us to see our reflection. Another fascinating phenomenon is diffraction, which occurs when light bends and spreads around obstacles or through very small openings. And then there is the quantum side of light. Light can also be thought of as being made of tiny packets of energy called photons. Photons have no rest mass, but they carry energy and momentum. The interaction between photons and matter is responsible for countless processes in nature and technology. Plants, for example, use sunlight in photosynthesis to convert light energy into chemical energy. Solar panels use light to generate electrical power. Cameras detect light to create images, while fiber-optic cables use pulses of light to transmit enormous amounts of information across the world. Even modern medicine uses light. Lasers can be used in surgery, vision correction, industrial manufacturing, and scientific research. And there is something even more incredible about light. Because it travels at a finite speed, looking into space is essentially looking into the past. When we observe the sun, we see it as it was about 8 minutes earlier. When astronomers observe distant galaxies, they may be seeing light that began its journey millions or even billions of years ago. So, light isn't simply something that makes objects visible. It is a fundamental part of the universe. It carries energy, transports information, interacts with matter, and allows us to observe objects across enormous distances. From the sunlight warming Earth to the photons reaching telescopes from distant galaxies, light connects us to the universe in ways that are almost impossible to imagine. And perhaps the most amazing thing about light is that something traveling at nearly 300,000 kilometers per second can reveal the history, structure, and beauty of the universe all around us.